Hello everyone. In today's video, I will try to modify an old UPS into a sine wave inverter. In my hand is a UPS designed for computers. This UPS has a power rating of 500 volts, about 300 watts, and it can supply power to a computer for around 15 minutes after a power outage. Normally, after a few years of use, it is removed from the computer system and sold for only about $1 or $2. Inside it, you can see a compartment for the battery and a circuit board on the top. The circuit board has a structure quite similar to common inverters that use a switching transformer. Apply a 12-volt power supply to the UPS and press the start button. We can see that the output waveform is a square wave with an unstable frequency. Moreover, this UPS will automatically shut down after about 20 minutes, regardless of whether the battery still has power or not. This is very inconvenient if you want to use it as an inverter. In this video, I will solve all of these limitations. Let's get started. I would like to express my sincere thanks to JLCPCB. They have been very generous in sponsoring PCBs for my projects. Many of my projects probably would not have been possible without their support. I will show you the simplest way to order PCBs from JLCPCB. First, you need to register an account. You can quickly sign up using the link I placed below this video. After that, upload the Gerber file that I provide. Once the Gerber file is uploaded successfully, you can perform a final check of the PCB using the built-in 3D viewer tool. This tool is very useful because it allows you to easily check for design errors and preview what your PCB will look like after it is manufactured. Next, you can choose the PCB color, PCB material, and many other parameters. After completing everything, you can add it to the cart and proceed with the payment. Don't forget to apply the discount coupons to optimize your PCB cost. JLCPCB is currently offering great promotions for new users. Go ahead and sign up now. My PCB arrived after about 2 weeks. Of course, the shipping time also depends a lot on the geographical distance and the actual conditions. If you want it faster, you can choose air shipping, but the cost will be much higher. The PCB is excellent as always. This is a mini hot plate. It helps you solder surface mount components quite easily. Of course, it is only really useful when working with small circuit boards like this one. For larger projects, my recommendation is to use the PCBA service from JLCPCB. With their large component inventory and modern equipment, they will definitely deliver great results. After finishing the control board, I will proceed to remove the original microcontroller from the circuit. Our goal is to replace the original microcontroller with a new one. This will change the way this UPS operates. This is what it looks like after I soldered the wires into the correct positions. I also added an LC filter to the output of the UPS, using a 2 mH inductor and a 2.5 microfarad capacitor. At this point, about 90% of the work is complete. Testing with a 60-watt incandescent light bulb, the output waveform, voltage, and frequency are all very stable. The downside here is that the efficiency is quite low, only about 85%. The heatsink is fairly small, so we will need to add a cooling fan. With an inductive load, a 45-watt fan, it also works very well. The output voltage and waveform remain very stable. This is the circuit board of a UPS from the TG1000 series. It has twice the power of the TG500, with a maximum output power of 600 watts. It operates with two 12-volt batteries connected in series. I modified it using this mod module and tested it with a 1/2 HP water pump. This pump has a startup power of about 2 kilowatts. However, with the soft start function, the pump still operates very well.
Ok nhá. Chạy được máy bơm nhá. Chạy máy bơm ok luôn. Tắt này. Đấy, tắt máy bơm nhá. Khởi động lại máy bơm này. Đấy. Chạy ngon luôn. Tắt này. Rất là ok luôn.